Okay, welcome back. As I told you that we have for measuring or counting, calculating the total or the water demand for a city or for any area, we need to know the main points. The main point that we have is how many people is there and how much they will be after a certain period of time, which means we have to make them forecasting anyway. But finally, when we have the number of the citizens in that area, we will multiply them by a number which is the consumption rate. Consumption rate, it means how much is the liter per capita per every day, per each person per day that they need. Then this is called domestic use. The uh, Usually, as an engineer, and you may say, how supposed to I know how much uh, industries in that area, how much I supposed to have number of schools and so on. But in case that this is a rapid estimation, the domestic will make 50% of the total demand. So means what? Means in case that you counted for example, the area in that area. For example, if you counted the domestic was 1,000 meter cube per day. So I can say the total demand, which include the domestic plus industry and plus uh, commerce and plus what we say public and the leakage. So all these there is will be just equal to the one this one. It means that it's supposed to be equal to the same or close to that one. So I can say the domestic will make up 15% of the total demand. The other 50 will include the rest. Means if I don't have any idea on this one, this is a rapid estimation. So the total demand is equal to that 1,000 times 2. 2 times 1,000, because we said this is the 50%. The rest, it will be the same as the domestic and goes to the industry, commerce, implant, and all the others. So that means that in this case, we need to have 2,000 meter cube. This is a rapid estimation, okay, as an average. Now, what are the main factors? What are the main factors that affect on the demand? So, small cities needs small, less quantity of waters. Huge or large cities needs more. It means the size of the city will play a role, and industry and the commerce are also having the size of the industry itself will play a role, and the number of the industries in that area also play a role, and peoples in that area, the characteristics means the living level, the level of living in that area. For example, for rich countries, or let me say educated peoples, we have it will related educated peoples and non-educated peoples. There will be a difference in the consumption rate. The metering of water. So as much as you have water metering, the device that we latestly place it in the houses as the many governorate. So will help to minimize or maximize. Maybe the you will try for the first month. I will see. Oh, I have got a very expensive bill for water, so that will you will just record the metering and you will try to use less than one. So metering will kind of the control of the quantity of water. Also, how much is the price per 1 meter cube of the water that will be offered to you? For example, if it was cheap enough, so you may use more than you need. So if it was high or expensively or no, not lower level, so you may um, uh, consider that point and use less quantity. And also presence of the sewer system. Sometimes if you have a sewer system in the city, you may need less quantity. If you don't have sewer system, you may need to use water flushing. And other factors like climatic, quality, pressure, and all these maintenance in the cities all affect directly or indirectly on the quantity of the used water or the of the water that will be used for this area. Yeah. Now, this is for domestic. For domestic, we need to know how much is the percent per person's rate, and then we'll multiply that to ones, and we'll look after the other portions of the public sectors maybe, and to find the total demand. There is one more point, one more other point here, very important to us to know and to calculate the water. That's in case of having a fire in that city. So usually the fire will be extinguished by spray of water. Now, what that means you need to have water for that case. So what we have to do, we have to spread the point, which is called fire hydrant in the city. And besides of the fire hydrants, we should have firefighters, cars, trucks, and they will help. But the main point, the main important thing is we have to at least in our calculations we have to calculate for the worst condition is the when we have a fire, and then we have to have sufficient amount of water to just extinguish that fire. Now, means what? Means you have to account for the domestic plus for the fire separately and then add them together and you say that, no, this is will be the average demand for that area, including fire demand. Now, to know that how much is the quantity Q fire that we need, so we have Q domestic, that was for the domestic we need for the fire. So what will be the fire and how much we need to fire? Basically, the fire demand or the water that need for extinguishing fire, it will be, or it was found by the insurance companies, the people that have companies for insurance. So they need to know how much it will be the price of water. Then they have a sort of equation, empirical equations. Um, for example, people say that I have an insurance of on my house, so I have to pay. So they will look at your house, and then they tell you that you need to pay per month, for example, that much of the dollars. So they will ask, how did you found that one? They say that, oh, your house is built from from wood. So in case that if you have fire in your house, it will need more water. It will need more. The disaster will be more than if you have a brick concrete houses. So there will be a sort an equation that will govern the firefighting water demand. Then, before that, let me just give you a brief introduction to this firefighting system. We have two types of firefighting system. One of them, it will be inside the building, like we have a hose reel and sprinklers. Sprinklers will be in the ceilings, and the house shields, it will be as a roll that we have it. You can see it in everywhere. The outside building for fire, it will be usually fire hydrants. What are the fire hydrants? This is a fire hydrants, and the fire hydrant itself are made for having, it will be a source of water. So the fireman's or the firefighting man's stripes will just come here and open this screw and connect their hoses and use it as a source of water. Then there will be one, two, three. Usually there will be three sources, three openings. It means you can, in one time, you can use three tracks. Now, how did we use this one? So basically, this fire hydrant is designed for at least to have 250 gallon per minute. This GPM, by the way, GPM means gallon per minute. So 1 gallon per minute means 1 GPM. It's 1 gallon per minute. 1 gallon per minute. And be aware that whenever you want to convert gallon to liter, so you have to multiply it by how much. 1 gallon is how many liters? Anyone?
12.
Yes, how much?
12.
No. 1 gallon is, think
6.
about, no, make it lower. When you are using the gallons, usually it means that you have about 4 liters. It will be 4.2 liters if you are using the American style gallon, American gallon. So American gallon is 4.2. The other gallon, the standard gallon, is 3.785 liters. So usually use this one, please. In case that you need to convert gallon to liter, use 1 gallon is equal to 3.785 liter. So these fire hydrants are designed to at least to be to support, to give discharge for 250 gallon per minute, and it means that in 1 minute they will give, this can give you a 250. And how this will give you, so it will be basically connect to a main pipe. So there will be the main pipeline, the main distribution pipeline in the city. You have to convert to connect it between the fire hand directly to this one. Just we need to have a valve. This is a valve. The valve, it will be just in case that we have to just open this screw and the water is coming here, and then so what we should do, we will open this one and connect the hose of the truck, and then open this valve. This is we will have a water inside this one. In case you want to close this one, just close this one, and this is a key. We know that you need to have a key, a road about 2 meters road, and so then you have to just close that valve. And look at the valve is 6-inch valve. It means the pipe should be here 6-inch. If you are using a 4-inch pipe, 4-inch means 120 millimeters. So you have to use a valve here, which is called 4-inch valve. Now this pipe is the pipe that's connecting to the main pipe, and usually this is 8-inch. Then there will be 6-inch, and the valve it will be 6-inch, and then it will be connected to this one. By the way, this house should be above the ground by at least 18 inch. It means 1.5 feet. Okay, now we have to be aware that we have different colors. Fire hydrant itself are classified based on the colors. We are usually familiar with the red one, right? Uh, is that this is such kind of coding, color coding, or is there any meaning for that? Yes. Usually is the red meaning, it means that this can give you a 500 gallon per minute. So whenever you saw that one, it means that the capability or the capacity of this one will be, and usually this is will be used for the area, the domestic area. We have orange one. Orange one is it can be give you the capacity of having deliver water from the orange 500 will be more than this one, about 500 to 1000. So the green one can give you 1000 till 1500. The blue one, which can be used in the let me say very explosive area, it will give you 1500 gallon per minute. So that's why we have a different color coding. Excuse me just one second. I'm so sorry about that. That's what was the what's the color coding. Do you have any question about this? Hello?
No, sir. Thank you.
Okay.
Thank you, sir.
Okay, welcome. Just so we know that we have a fire hydrant. So do there is there any kind of specification for the a fire, standard fire? Yeah, there is a standard fire. The fire that we are talking about, we are going to calculate the water for it. It's called a standard fire. This standard fire is a fire, means that when we are going to calculate the fire in the city, we are going to calculate for one fire alone, one fire per day. So the gallon per minute that's needed from to be submitted, the 500 gallon per minute, it will be 500 gallon per minute per one fire per day. This is will be enough just for one fire per day. It means that if you have two fire, you have to multiply this number by 2. Okay, 3 fires. Okay, and the fire that we are talking about is the fire that will not longer than 10 hours. It will be between 4 till 10 hours. No more than 10 hours. It will be between 4 to 10. Uh, uh, Also, we have, yeah, this is the fires. So usually the fire requirements per 1 hour. If I say that the 500 gallon per minute can be classified for a fire of 4 hours, duration, we need to have 1000. If I have a fire for 5 hours, this will be for 1000 to 1205, and so on. So the maximum demand for the water for extinguishing a fire, which is long, for 10 hours, the time duration will be, it will be no more than 2250 gallon per minute. That's the main. It means that if you are going to estimate a water for a city and there is a fire and this fire will come with 5 hours, so the 5 hours will be, you have to pick one of these two numbers, and usually you will take the ultimate one, which is the 1250 gallon per minute. Then after that, I have to add this number, and basically I will give you this table in the exam. Okay, I will leave the other part of this first, as it's the first lecture. We will come and continue with this lecture for tomorrow. And I want you to just have just view this lecture note, read it, and we will meet tomorrow. In case that you don't have, do you have any question, please?
No, thank you very much, sir. Have a nice day.
For you too.